Hi everyone, today I am going to teach you a chapter number 2 which is of class 10 linear equation in two variable. In this first topic I am going to teach you the solubility of condition of the linear equation in two variable through the graphical method. So we have mainly the two methods to check the solubility of the linear system of the linear equation system. We have the two method, one is the algebraic method and one is the graphical method. That means through the graph, let's suppose we have the graph and we have the two line. So through this it represents the equation like the x plus y is equal to 4, and it represent also any equation like the 2x plus 3 is equal to 7, and anything. Both the two lines represent some equation. So in this way I am going to teach you how to find the solubility condition of the linear equation in two variable. That means when you get the two lines over a graph, then you will able to say that these two lines have a common solution, not common solution, and like this. Before this I would like to introduce you how to make the graph from equation. Like this we have the like this one, 2x plus 3 is equal to 6. So how will you make the graph of this? Let's suppose we have this one is the 3y. So as we get this one equation, so we have to construct the graph through this equation. So how will you construct? Before this you have to draw coordinate system which you have studied in class 8. So this one is the 1, 2 and 3, and this one can be written as the 1, 2 and this one 3, and it is in the all in the minus. So here we also get minus 1, minus 2 and the minus 3, and another here we get the 1 and here the 2 and here the 3. So as we get the coordinate system and we have an equation which is the 2x plus 3y is equal to 6. So it is a linear equation because the highest power of the variable is the 1 and the highest power of variable here is also 1, and these variable are the called the two variable because we have the one variable x and one variable y. This is why it is called the linear equation in the two variable. So how will you construct? So that you have to find the value of the x and y, then you will able to construct. So make a table x and y. So as you made a table, you have to just find only the three values, or also you could make the graph through the two values, but the three value will be more accurate for you to making the to construct a graph. So let's suppose we kept the value of here the x is equal to 1. So this becomes the, if we have put the value of x is equal to 1, so it becomes the 2 plus 3y is equal to 6. That means it become the 3y and it become the 4. Y is equal to 4 by 3. So but this value is coming in the rational number, or you could say it will like a fraction. So you have to get such values which are the in the integer form, so that you will able to construct the graph very clearly. Also you could construct, but you will get confused, so that I would like to tell you to keep such values of the x or y, so that you will get the value in the integral form. So let's suppose we put the value x is equal to 0. So when you put the x is equal to 0, then this whole becomes the 0, and it's become the 3y is equal to 6. That means y is equal to 2. So here we get the y is equal to 2, and like this when we put the y is equal to 0, that means the x is equal to 3 we will get. So I think I get it to how to solve this. How to find the values of the variables x or y to draw the graph. So as we get here the two values through which you have to construct a graph. So as we have to draw the 0, 2. So that means x coordinate is 0 and y coordinate is 2. So this point we get, and through the second, as we have the x coordinate is the 3 and y coordinate is the 0. That means here we have to the second point. Join those two points. So this is going to be the graph of this line. So this line can be written or said as the 2x plus 3y is equal to 6. So I think you understand how to draw the graph of a linear equation in two variable. You have to find the values of the x and y and put into the equation which satisfy this one, and then you are able to construct the graph. On this basis we have the condition of solubility. Let's suppose we have this one is the equation, and let's suppose we have the another equation like the 4x plus 3 is like the 4x plus y is equal to 7. So as we have, let's suppose we have this another line, so may it will also produce a somewhere line like this or anything. Can it make when we solve this one we will get the exact answer what which type of line we are going to get from this equation. So that means any line, let's suppose this line represents the 4x plus y is equal to 7. So as you know that how to draw the graph of this equation by finding the values of the x and y which will satisfy this equation, and then you will plot on the on the coordinate system, then you will get the graph by joining the line. So let's suppose I main thing, my main intention is this, that I have to show the solubility of condition between the between the two equations, or which is called the system of equation. As we get here a line, the line, it is representing something like the, let's suppose the m comma x or the y comma n is equal to something the like the 5. So it represent a line. Let's suppose the another line we get by solving any other equation which is this one. Let's suppose it also represent the n comma x plus m comma y is equal to 6. So in this way we get the two when we plot the both have the different equation and have a different line or the graph of the, when we plot both of the graph on the same line, and as we are able to see that those both line are going to intersect at a point. So if it is going to intersect at a point, that means we have the two equation, one is this one and one is this one. That means in this both of the equation we are going to get a common solution. Let's suppose this point, so this point is going to intersect, that means this is one, taking the what is the value of this point, we will get like something, it is about the 6 from the x-axis and it is also 6 about the y-axis. That means 6 comma 6. So this one first term is called the x and this one is the y. That means these x and y's values will satisfy in both of the equation, in the equation first and in the equation second. In both of the equation this value is going to satisfy. So let's suppose the another example how to understand the condition of solubility. Just like we have this one coordinate system and we get this one as a line, and let's suppose we get the another line like this. So both are the different line, that means both line have the different equation, and is there any common solution having both of the line? So this line representing have no common solution in both of the equation. Why you said? Because even though you don't know the equation, what is the equation, so how will you say that both equation have no common solution? Because both line are parallel to each other. This is the condition of solubility first. If the two lines are parallel to each other, that means there is no common solution between the two equation. And the second thing which we have, that is this one. When we get like a line like this one, and when we get the another line of the this one, you must understand that both of the line represents the different equation in the two variable. So like this it is also represent the two line represents the two variable two equation. So that means here we get a common point, both intersect each other. That means there is a one common solution which exists between the two different equation. And the another condition we have to study, one third one, which is when the two lines are coincide. That means this one is the line, and let's suppose this one line we get through the first equation. Let's suppose this is the x plus y equal to z. We have the equation like this one. So through which we get this one this one line. Let's suppose the another equation we have, that 2x plus 2 of y is equal to 4. This is also another equation, but this equation also construct the same line. That means both of the line coincides each other. That means we have the infinitely many solution between both of the equation. So we get the three condition. When the lines are intersecting, that means one solution. When the lines are parallel, that means no solution. And when the lines are coincidence, that means we have the infinitely many solution. I think you understand. Thank you for today.